Okay, welcome to Math 7, Chapter 5, Section 8. We're almost done with the chapter. This is a really important concept, and we are learning how to solve inequalities using multiplication or division. Okay, so we're going to perform a couple of experiments on some inequalities so that you can discover something. We're going to see what happens. We're going to see if an inequality is still true. Still a true statement when we multiply or divide both sides by a positive. So we're going to try this little basic inequality. We're going to try it with multiplication and division. So, is this a true statement? Is 8 greater than 2? Yes or no? Is 8 greater than 2? Yes, 8 is greater than 2. So we're starting with a true statement. We all agree? Yes. 7M agrees. Okay, 8 is greater than 2. So let's try this. Let's try multiplying both sides by a positive. Somebody give me a positive. Juliana. 4. Okay, we're going to multiply both sides by 4. And we're going to test this to see if it's still true. So I'm putting a question mark saying we're running a test. This is an experiment. 8 times 4 is 32. And 2 times 4 is 8. So, do we have a true statement?
Yeah.
Is 32 greater than 8?
Yes.
Yes. True. Okay, how about division? Give me something to divide these two sides by. Chris? 2. He wants to divide by 2. Okay, so we're going to test this to see if this remains a true statement. 8 divided by 2 is 4. And 2 divided by 2 is 1. This is still a true statement. Okay, so if we multiply both sides or divide both sides of an inequality by a positive value, the inequality remains true. Very good. So the next question is an inequality still true when we multiply or divide both sides by a negative? Okay, let's try this. Rachel? And that's recorded. Rachel, is 8 greater than 2?
8. Oh, there's 8 greater than 2. 8 greater than 2, yes.
8 is greater than 2.
Yes.
Does everyone agree with Rachel?
Yes. Yeah.
So we're going to do this. We're going to just use a very simple factor. We're going to multiply both sides by negative 1. Negative 1. Okay? And so, does the statement remain true? 8 times negative 1. 8 times negative 1 is?
-8.
And 2 times negative 1 is?
Negative.
And which of these numbers really is greater? Negative 8 or negative 2?
-2.
Look at the number line. Negative 2 is on the greater side, right? Negative 2 is to the right. So this is false. If we wanted this to be true, we would have to write, when we compare these two values, we would have to switch the sign. Okay? When we multiply both sides of an inequality by a negative, we are going to have to switch a sign in order to make sure that the statement is true. Okay, let's try it with this. Again, we're going to end up with the same values, aren't we? When we divide both sides of an inequality by negative 1, we just change those signs. So is this statement true? Is it still, the left still greater than the right? No. So we're going to have to switch the sign. This is false. We're going to have to switch the sign, and now it's true. Okay, so make sure you write the important rule. We must switch the sign. Keyword. Switch the sign. Okay, so we're going to write this discovery as a rule. Multiplication and division properties of inequality. Let's start with what happens when we multiply both sides or divide both sides by a positive. We know that when we multiply or divide both sides by a positive, the sign stays the same. So as a rule, we'll use our variables to say, if A is less than B, and a factor C is greater than 0, then if we multiply the left side of this inequality by C, what else must we do? Wesley? He says we need to multiply the other side by C as well. Good. And if C is positive, does that change the sign? No, we're multiplying both sides by a positive. So look at, the sign has remained the same. If A is less than B and C is positive, then if we multiply both sides by C, the sign stays the same. Okay, see if you can write the rule for this. If we're multiplying or dividing both sides by a negative, show how the sign will change. We can use the same statement. If A is less than B, but now C, the factor that we're multiplying by, is less than 0. If C is less than 0, what kind of a number is that? Liam, do you know? We're going to multiply both sides of this by a number that is less than 0. What kind of a number is that? Good, it's a negative. Good. You understand why we have that part of the rule? Right? We're saying that that value is negative. Then, how do we finish it? It's going to look like this one up here, but we're multiplying both sides by a negative, right? So, how do you finish it? Hannah? AC. Okay, we're going to multiply both sides by C, right? So AC is, very good. She's changed the sign. Greater than BC. You see that? This sign is not the same as was in the hypothesis. This is a hypothesis over here. This is the conclusion. Okay? So, and that's the sign switch that happens when we multiply both sides by a negative. Okay, so here are two inequalities to solve. And watch how we do this, because there are some safe steps to doing this. So first we say, what do we need to do in order to get T isolated? Isabella, what do we need to do? By? We're looking at this one here, number 1. What are we dividing T by right now?
6.
So what are we going to multiply by? Right, we multiply by the inverse. We're going to multiply both sides by 6. So before you do anything else, write that in. Both sides are being multiplied by 6. And then ask yourself this. Is there a sign change? Yes or no? No. No. So go down and write your sign before you forget. Okay? And now we can go back and simplify the left and the right. But it's important that we stop and say, did this inverse operation we're using cause a sign change? Ask it right away before you forget. Okay? And then we say 6 over 6 is 1, so 1t is greater than 24. 6 times 4, 4 times 6, 24. Okay? The second one, number 2. Courtney.
Oh no.
What are we doing to t right now? What is happening to t?
It's the sign.
Wait a minute.
It's being multiplied
by negative 3. Good. So now what are you going to do?
Switch the sign.
What are you going to do to get it alone? Operation.
Division.
By?
Negative.
Excellent. She says divide by -3. So write that in and then ask yourself, is there a sign change? Courtney?
Yes.
Very good. She says there's a sign change, so we're going to go switch it before we forget. Switch the sign. And now we simplify.
We have to tell if there's a sign change.
How can we tell if there's a sign change? Juliana?
If it's negative.
We're dividing by a negative. We're dividing by. We're operating with a negative. See that? That's why. Multiplying or dividing by a negative. Okay, check your work carefully today to make sure you're doing it right with the key. Okay, and I'll come around and check you. But over here we have T, and what do we have on the left side, everyone? -9. Good. Okay, we have one more to try. Okay, last one we'll try together, and then you have your assignment. So, -2/3 K is greater than or equal to 8. Who remembers the one step we can use to get this isolated? Okay. Turn to your neighbor and tell him what it is. Did she say it? Okay, who has it now? Who has it now? Anyone else? Ryan has it. Okay, Ryan.
Would you multiply by 3?
If we times by -2/3, do we eliminate the -2/3?
Yeah.
What can we times so that we eliminate it?
3/2.
Good. We use the reciprocal, right? Multiplicative inverse. So multiply by the multiplicative inverse. Does this cause a sign change?
That's kind of.
Are we multiplying by negative, Charlie? Do we change the sign? Yes, we do. Go down and change it first before you start simplifying and before you forget. This is 1, which is great. We want 1K. On the right, we can do a little bit of reducing, right? 8 divided by -2 is? 8 divided by -2 is? -4 times 3 is? I think you were multiplying, weren't you? K is less than or equal to -12. Okay? Please follow those steps. Show the operation you're going to use. Change your sign before you simplify, and you'll be safe. Okay? Here's your assignment. There you go. And you have 25 minutes in class to complete this. And just in case you're watching in Minnesota, that's for Riley and Olivia this year from your fellow friends at St. John's.